Welcome back. We left off last time talking about general angles, and so let's draw a circle and we'll talk about how we can relate general angles, arc length, and theta. So if we have a circle with radius r, right, and we rotate the radius counterclockwise, we'll get an angle theta here, right? Well, there's an equation that will tell us the distance around the circle that's inscribed, the part of the circle that's inscribed by the initial angle and the terminal angle, the angle theta, initial side and terminal side, and that equation is simply S equals R times theta. So we can get a section of the circle's length by multiplying the radius times the angle theta. Related to that is a side equation. The area is equal to 1/2 r squared theta. You just need to know how to use these. You don't have to memorize them, and we'll go over a quick example right now. So if we have a baseball diamond, okay, and the outfield needs to be fenced, okay, we'll say this distance out here is the fence that we need to calculate. And inside of here, we have the baseball diamond. This is second base. This is third. This is first. The pitching mound is there. And this distance from home plate to the very edge of the outfield is known as 180 feet. Okay? So, two questions. How much fence? And how much fence do we need? So we need to calculate a length. And what is the area of the entire field? Find the area of the field. Okay, so let's do A first. So A is a very straightforward application of the equation S equals R times theta, right? But the thing you have to remember about these equations is you have to be in radians, okay? Be sure to be in radians first. Okay, before you use S equals R times theta. Well, what is the angle theta that we're talking about here? All right, if we start here, right, positive x-axis, can you imagine this is standard coordinate axis? And we rotate to there, the angle theta in radians is pi over 2. It's a 90-degree angle, but the equivalent in radians is pi over 2. So we can calculate it. S equals 180 feet times pi over 2 radians. So the output is going to be, can you see that it's 180 feet times pi over 2, which simplifies to 90 feet times pi, right? Which is equal to 283 feet, okay? Just one multiplication, really, R times theta, with a little bit of dimensions there. So for the area, what do? we just simply use the equation area equals 1/2 r times theta. So we have area equals 1/2 r squared times theta, right? So in this problem, r was given as 180 feet. So now we do 180 feet raised to the second. That will give us square feet, and then we times that by pi over 2, the radians, angle measurement of the entire field. And so now we can do this. This is going to be equal to 1/2. Evaluated in the calculator, it comes out to 32,400 feet squared times pi over 2. This is now 32,400 feet squared over 4 times pi, excuse me. And evaluated in the calculator, that comes out to 25,434 feet squared. Okay, and thank you for watching.